Good morning, everyone. This is Rashakari from Mechanical Branch in Srinivasa Ramanjan Institute of Technology. Today, my topic is Bezier Curves, Constructions, Properties, and Applications. Subject name CAD/CAM. Subject code 23MEC 602. My roll number 234G 1A0322. Introduction to Bezier curves. Bezier curves are parametric curves frequently used in computer graphics and designs. They provide a simple and flexible way to model smooth curves. Understanding their construction and properties is essential for various applications. Hist- Historical background. The curves were developed by Bezier in 1960s for automotive design. They have since become a fundamental tool in computer-aided design (CAD). Their mathematical foundation has evolved, influencing many modern graphics techniques. Basic definition of Bezier curves. A Bezier curve is defined by a set of control points influencing its shapes. The curve is a weighted sum of these control points parameterized by t. The degree of the curve is 1 less than the number of control points. Construction of Bezier curves. The construction utilizes the Bristolian polynomial basis of interpolation. The algorithm linearly interpolates between control points to generate the curve. Control points and the curve. Control points determine the overall shape and direction of the curve. The curve generally does not pass through all control points except for the endpoints. Moving control points alters the same, providing designing flexibilities. Properties of Bezier curves. Bezier curves are contained within the convex of their control points. They are often invariant, meaning transformations preserve their shapes. The curves are smooth and have continuous derivatives, making them visually appealing. Endpoints and tangents. The curve always begins at the first control point and ends at the last. The tangent vectors at the endpoints are aligned with the adjacent control points. These properties allows for precise control over the curve's start and end directions. Degree and complexity. The degree of Bezier curves influences its complexity and flexibility. Higher degree curves can model more complex shapes but are harder to manipulate. Common degrees used are quadratic and cubic. Quadratic degree number is 2 and cubic number degree is 3. Quadratic Bezier curves defined by three control points forming a simple parabolic shape. They are widely used in the vector graphics for their simplicity. The curve can be easily manipulated by moving the middle control point. Cubic Bezier curve defined by four control points offering greater flexibilities. They are the most common in graphic design and font creation. Their shape is controlled by the positions of the two middle control points. Composite Bezier curves and splines. Multiple Bezier curves can be joined smoothly to form complex shapes. Continuity conditions ensure some smooth transitions between segments. These composite curves are fundamentally in designing complex models. Properties in design and graphics. Bezier curves enable precise control over shapes in vector art. They are used in the font design, animation paths, and interface elements. Their mathematical properties ensures predictable and smooth curves. Applications in computer graphics. Bezier curves are used for drawing smooth lines and shapes in digital images. They form the basis for vector graphic formats like SVG and PostScripts. They facilitate scalable and resolution independent graphics. Applications in CAD and CAM. Bezier curves are essential in designing automotive and aerospace components. They help in creating smooth surface and complex geometries. The flexibility allows the flexibility allows for iterative design and refinement processes. Animation and motion paths. Bezier curves define smooth motion paths in animation software. They allow animator to control acceleration and timing processes. This enable realistic and fluid movements in the digital animations. Advantages of Bezier curves. They provide initiative control with a small number of control points. They are efficient and easy to implement. Their, their mathematical properties support smooth and scalable designs. Limitations and challenges. High degree Bezier curves can be difficult to manipulate efficiently. They may require many control points for complex shapes, leading to complexity. Alternates like B-spline and sometimes preferred to for greater flexibility. Summary of key concepts. Bezier curves are defined by control points and constructed via decastalizing algorithm. They possess properties like convex, hull, containment, and affine invariations. Their applications span graphics design, animation, and engineering. Conclusion and future directions. Bezier curves continue to be a vital tool in digital design and modeling. Advanced include their integration into more complex spline and surface models. Ongoing research aims to enhance their flexibility and computational efficiency. Thank you. So this is my CAA assignment for CAD-CAM. So thank you for thanking you this opportunity.